Okay, here we go. First of all, let's prove that that angle equals that angle. Sorry, that angle is congruent to that angle. And you know what I'm going to do? I know that has to be the last statement. I'm going to copy that. I'm going to paste that down here. And the last statement, I'm using Control-Shift-V so I don't retain any of that formatting. Now, I need to have two overlapping linear pairs. And they need to overlap in such a way that if I remove the overlap, what remains are these two angles. So I've decided to use this linear pair and this linear pair. The overlap will be FDH. When I remove angle FDH, I'll have EDF, one of the angles I'm trying to use, and GDH, another angle that I'm trying to use. Okay, well, this D is bugging me. That's supposed to be the same size as the others. Much better. Okay, so it says find two overlapping linear pairs. So the first linear pair I decided to use was EDF and FDH. So I'm going to post those in here. Control-Shift-V. Let's see how much room I have to type. Linear pair. Well, I'm going to tempt fate and stretch that a little bit. All right, and we're not using the congruent sign. We're just talking about two angles. Those two things are linear pairs. Now I know I'm going to be using EDF and FDH several more times, so let's be smart about this. We'll use those down here. We're going to alter them, but we might as well reuse them. How do I know that that is a linear pair? It was given to me in the diagram. I can reuse the word diagram over here when I talk about my other linear pair. Okay, my first linear pair was this pair of angles. My next linear pair will be this pair of angles. So GDH and FDH are a linear pair. Let's go reuse some of my work from over here. Paste that in there, and it is no longer EDF. It is no longer mistake. Okay, good. So here's my first mistake. It should be this angle and this angle, EDF, FDH. So let's go fix that over here. Got a little too confident with my copy paste. All right, now this angle and this angle, this should be GDH and FDH. Let's double check. GDH and FDH. Okay, so that's this pair of angles. Going to run down the right side. And then this pair of angles, going to run down the left side. EDF, FDH. Notice if I've done this correctly, I have FDH on both sides. That's what we'll be subtracting later on. Let's go fix where I had the wrong letter here. Okay, I have other work to do there also. Each linear pair is made up of two supplementary angles. Okay, so now I can say that those are supplementary. I'm just going to type it like that. So let's go grab this, and we're going to say that those two things are supplementary. How do we know that they're supplementary? The linear pair postulate says if you have a linear pair, they are supplementary. I think I have room for that. Let's reuse that over here. What is the meaning of supplementary? It means that when I take the measures of those two angles and add them together, I get 180 degrees. On your own computer, you'll probably be zooming so you can see some of this stuff happening. I don't know if I have room. We'll figure it out. All right, so am I missing my angle sign? I am, and I'm missing my M. I should be able to copy both of those and paste those there. Okay, and it wrapped. I'll deal with that. Let's just double check. EDF should be FDH. EDF, FDH. EDF and FDH add up to 180 degrees. For full credit, include the degree sign. Where do I get the degree sign? Insert it from special characters. Type out the word degree and it'll show up. And let's do some, okay, so how do I know that? That is the definition of supplementary. That's good enough. I'm going to use that again over here. And I'm going to reuse this pair of angles right here. And I'm going to reuse equals 180 degrees right here. And this is meant to be addition. When I add them together, I get 180 degrees. We're not going to leave it wrapped like that. We're going to fix that. Anything worth doing is worth doing well. Measure twice, cut once. A bird in the hand is worth two in the bush. All right, so why is it floating up there like that? I think there might be an extra space somewhere. There it is. I'm going to go back and double check again. GDH, FDH, those should be a linear pair. GDH, FDH. EDF, FDH should be a linear pair. EDF, FDH. Notice, I will be at some point taking away FDH from both sides of something. Well, here we go. The moment of truth. If that quantity equals 180 and that quantity equals 180, then they must be equal to each other. Do it. There you go. Because of the transitive property. If A equals B and B equals C, then A equals C. Spell it out. We love that transitive property. Here we go. Subtraction property of equality. We're going to finally take away the FDH from both sides. Okay, I have an extra space. Subtract. Let's call it, let's see if we can get away with subtraction prop of equality. The whole name is the subtraction property of equality. Now, how can we change that statement about numbers into a statement about angles? We're going to use the definition of angle congruence. We'll see if we can fit that in there. There we go. Double check. Did I finish with what I claimed I was going to finish with? Angle EDF is congruent to angle GDH. Yes, I did. Let's check that these pairs work together. EDF, FDH, EDF, FDH, EDF, FDH. Let's check that these pairs work together. GDH, FDH, GDH, FDH, GDH, FDH. In other words, I didn't accidentally replace or drop a letter. Let's check our relationship operators here. Ampersand, 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 plus, plus. Got my degree sign, and I think we're done. Enjoy.